Countdown. Nothing happened. All right. 45. 45, we've got this one, right? We got integral, and we're going from 1 to 4. We've got e to the square root of x over the square root of x dx. So we saw one kind of similar to this yesterday where we want u to equal the square root of x, but we're going to leave this down here in the denominator as sacrifice, like we're not going to substitute for u there. When we take the derivative over here, we get 1/2 x to the negative 1/2, which is also known as 1 over 2 root x. I'm going to keep saying it. It's super helpful if you just know that the square root of x goes to this instead of messing with the in-between step. If you just know it's 1 over 2 root x, it does help sometimes. You end up with 2 times the square root of x du equals dx. Okay, so we're going to substitute in. We have e to the u. We're leaving that square root of x in there. We're replacing dx with 2 root x du. And then those square root of x's cancel. Okay, that's how I'm getting rid of the x's in there. I have to change my limits of integration. So I've got 1 and 4. I'm taking the square root of both of those. So it's going from 1 to 2. Integrate. When we integrate 2e to the u, we get 2e to the u. We're going from 1 to 2. So we get 2e squared minus 2e to the first. Not really anything you can do with that. At best, maybe you factor out a 2. I don't know. 2e to the second minus 2e to the first is great, if you can get to that point. Any problems with 45? Definitely, though, leaving one behind there so that it'll get canceled by the derivative is helpful. 46. 46, we've got the integral of 0 to pi over 2. We got cosine x times sine of x. We graphed this in third hour. It was very disappointing. It was not, it was just a regular old looking sine wave. So probably on this one, want to substitute for u equals sine of x here. It's inside of the sine function. And also when we take the derivative, we get cosine. That's going to cancel that cosine out front. Okay, so du over cosine of x equals dx. Have you caught on after doing 20 or so substitution problems that it's always du divided by whatever the derivative is equals dx, right? It's the same kind of thing. Happens every time. Okay, sine of 0 is 0. Sine of pi over 2 is 1. So we've changed our limits. We've got cosine of x. We've got sine of u. And then we've got du over cosine of x dx. Cosines cancel. Left with the integral of sine. Integral of sine is negative cosine. It's going to be negative cosine of 1 minus negative cosine of 0. Cosine of 0 is 1. So we're looking at 1 minus the cosine of 1. Do you know what the cosine of 1 is? I don't know what the cosine of 1 is. I have no idea. I don't care. I'm just going to leave it as cosine of 1. Okay. It's not inverse cosine. It's just regular old cosine of 1 radian. Don't know what that is. Okay. Other problems, 46. All right, moving on, 49. Okay, 49, we have the integral from 0 to 1. And we got e to the z plus 1 over e to the z plus z. I'm very suspicious here because my denominator has a derivative that is the numerator. So if I just let u equal whatever is in the denominator there, and I take the derivative, it's going to conveniently cancel out what I have in the numerator right du over e to the z plus 1 equals dz. Multiply each side by dz, divide each side by e to the z plus 1. So we have e to the z plus 1 over u du over e to the z plus 1. 0. When we put 0 in for z, we have e to the 0, that's 1, plus 0. We put 1 in, we got e to the first, plus 1, so just e plus 1. These cancel. What is the integral of 1 over u? Natural log, absolute value, right? So we got natural log, absolute value of u, and we're doing this from 1 to e plus 1. That gets us natural log of e plus 1 minus the natural log of 1. Natural log of 1 is just 0. So final answer here, we got natural log e plus 1. No absolute value necessary because e plus 1 is a positive number. We don't need to have that on there. 50. 50, we have integral 0 to 4 x over square root of 1 plus 2x dx. What do we do here? How are we going to get rid of this x up here? Because if I substitute, I got u equals 1 plus 2x. My derivative would just be 2. So I would have du over 2 equals dx. I try and substitute in, I get x over the square root of u times du over 2. How, my friends, am I getting rid of the x? No, Xavier, I'm not burning it. What do I do?
Oh, u equals x.
What's that?
U equals x.
U equals x? You ever tried u equals x before? You know what it does?
Oh, it does.
You have the same thing. It's just got u's in it. I mean, if you're a big fan of the letter u, it's good, but it's not doing much for you. How we get rid of that x?
Solve for x.
Solve for x. So let's try it. So u equals 1 plus 2x. All right, I'm going to subtract 1, and I'm going to divide by 2. Is this really what we have to do? This looks like a mess, right? U minus 1 over 2 equals x. Oh boy. Let's try it. All right, so that would give me u minus 1 over 2. We'd have a square root of u in the bottom. We got this here. Okay. If we change everything to u, we would have to change our limits of integration. That would give me a 1 here and a 9 up here. I've got 1/4 that I can pull out of that integral. Is this an integral that I can do? Yep, but what do I have to do? Split it. Okay, so I got 1/4 integral from 1 to 9, u over the square root of u minus 1 over the square root of u du. So this is 1/4 integral from 1 to 9. This is u to the 1/2. This is u to the negative 1/2. And away we go. Okay, so we got 1/4 u to the 3/2 over 3/2 minus u to the 1/2 over 1/2 from 1 to 9. All right, 2/3. 2/3 times 1/4. 2/3 times 1/4. So 2/3 times 1/4, 1/6. 1/6 u to the 3/2 minus 1/2 u to the 1/2. 1 to 9. Okay, I put 9 in. 9 to the 3/2 power. 9 to the 3/2 power. I'm going to take the square root. I'm going to get 3. I'm going to cube that, get 27. 27 over 6. Put 9 in here. Get 3/2. Square root of 9 is 3. When I put 1 in, I get 1/6 minus 1/2. It's a lot of stuff. Make this all over 6. So make this 9 over 6. Make this 3 over 6. I got 27 minus 9. That's 18. Minus 1, down to 17. Minus a negative 3. So that's adding 3. I'm up to 20. It looks to me like I got 20 over 6, which would be 10 over 3. Complaints? Do you know that there's actually competitive integration where people go and they put an integral up on the board and two people go head to head and they try and see who can do it the fastest? And they're like outrageous integrals. They're ridiculous ones that would be. This is like, I think this is like a Stanford thing. It would seem like a Stanford thing, but there's like competitive math where you go head to head. Maybe we should do that in here. Maybe we'd liven things up a little bit. If there was an integration battle and it was me versus the rest of the math department, would you take me or would you take the field? You take me?
Yeah.
You like have enough confidence that I could take them all out?
Already tried this event. Remember when JK did the math problem?
Oh, it was bad?
Well, we went to Mrs. Vessel and we spent 40 minutes in there, and then we came in here and it took like 5 minutes.
Okay, well that's good to know. That's good. We needed that self-esteem boost. All right, 61. This is a ridiculous problem. Breathing is cyclic and a full respiratory cycle from beginning of inhalation to the end. There's too much backstory here. They give me an equation. Yes, equation. Use this model to find the volume of inhaled air in the lungs at time t. So what do we have to do on this problem? The maximum rate of airflow into the lungs is about 0.5. This explains why this function has been used to model the rate of airflow. This is the rate of flow. Use this model to find the volume of inhaled air at time t. Are we just integrating that? Yeah? Okay, so let's integrate it. So we've got the integral here of 1/2 sine 2 pi t over 5 dt. Out of all of that wording in there, that's just what they wanted us to do. So this is the best kind of book problem where they just give you some random equation and they put a huge story around it, right? So this is our u. We find the derivative here. The derivative is just going to be 2 pi over 5. I'm going to multiply each side by 5 over 2 pi. Multiply by dt. So we have here 1/2 sine of u. Then we got 5 over 2 pi du. So out of this, we can pull out a 5 over 4 pi. Integrate sine, get negative cosine. So negative 5 over 4 pi cosine 2 pi t over 5. So 62, I don't know if you got their humor here, but they have the Alabama Instruments to compete with Texas Instruments, maker of the calculators. Get it? No, it's not funny. They give the rate at which calculators are produced, and then they want the number of calculators from the beginning of the 3rd week, so when t is equal to 3, to the end of the 4th week. Would you go 3 to 4 here? Would you go 3 to 5? Like, how would you set this up? You think? This is the rate of production here, and it's after t weeks. 2 to 4, 3 to 4, 3 to 5? What would you go with? Oh, that's a legitimate question. I don't know. Like, how would you think we should set this up? 3 to 4? Let's stay with 3 to 4. All right. Sure. 3 to 4. They want us to integrate this mess. 5,000. 1 minus 100 over t plus 10 squared dt. So I'm going to multiply by 5,000 here. I have 5,000 minus 50,000. 500,000. 500,000 over t plus 10 squared dt. Integral. Can I just do this? Can I go 5,000 t minus 500,000 t plus 10 to the negative 3? Nope, negative 1, sorry. Over negative 1. I mean, this is just, like I could let u equal t plus 10. The derivative there is just going to be 1. Doing u substitution isn't going to change a whole lot. I integrate 1 over u squared, and I'm going to get negative 1 over u. Right, so I'd have 5,000 t plus, I feel like I keep missing a 0 here, 5,000 over t plus 10. I did that from 3 to 4. Enough of this. We spent 16 minutes and 35 seconds going over the homework. That's what the little timer says on the bottom. We're done with homework. Enough with that. Okay, we got delta math today. We want to know how to do delta math, right? So delta math, you're going to encounter a couple of problems today. We want to clean up and finish off any potential integral we could see on the AP exam. So we have this base group of integrals that we know how to do, ones that have power rule in them, all the different rules. We did u substitution. The only other scenario that you might have on this exam still is a problem that looks like something like this here. So I'll write it on my paper and then show it to you in a second. We got this. I know you can see it on the screen, kind of. But this is one that we can't do substitution on, but is still in the AP guideline for something that you need to know how to do. So we have a polynomial on top, and we have a polynomial on the bottom. And right now we have something where the degree in the numerator, what is the degree in the numerator? 2 is larger than or equal to, like that would also be a possibility, than the degree of the denominator. So this is a potential strategy that we can use. We can't just break it up into 4x squared over x minus 2. That's not going to really get us anywhere, like over minus 15x over x minus 2. Not going to go very far. We need to have a way to write this in a different form that we're able to integrate. Okay, so what we're going to introduce today is long division. And we're going to go with the idea of way back, elementary school. If I ask you to take 25 and divide it by 3, how many times 3 go into 25? 8, with how much left over? 1. So would you agree that I could write 25 thirds as 8 and 1/3? Mixed number kind of deal. And would you also agree that when I write this, technically what I should write is 8 plus 1/3? Because when I write it like this, it looks like multiplication. But this is in actuality what we're talking about. We have 8 whole parts, and then we have 1/3 of a group left over. So this is our quotient. The 1 is our remainder. And the 3 is what we divided by, our divisor. Okay. We're going to do division up here, and we're going to write our answer in the same kind of form that we have here. Quotient plus remainder over divisor. All right, so I'm going to do x minus 2 divided by divided into 4x squared minus 15x plus 11. I know there's a lot of propaganda out there to do synthetic division. I don't believe in synthetic division. I know how to do it. I don't like to use it. I like to do the old school long division way. Why? Because I went to elementary school in the 1980s. Okay, that's how we did things. And also, just doing the regular long division always works, no matter what the scenario is. Synthetic only works if you're dividing by a linear factor. Okay, that's the only time synthetic division works. I'm just going to look at this and say, what can I multiply x by to get to 4x squared? And the answer is 4x. I'm going to do 4x times x. I'm going to do 4x times negative 2. What do I do next?
Subtract.
Yes, I subtract. I get paranoid about where I put my subtraction symbol. I put a little circle around it to remind myself that's what I'm doing. I got 0 here, negative 15 minus negative 8. I'm adding 8. I get negative 7x plus 11. Minus 7. Subtract again. I get 3. When my degree here is smaller than what I'm dividing by, it's time to stop. This is my remainder. This up here is my quotient. You're like, great, Mr. Tubby, long division, awesome. Just going to use that to write this integral in a different way. I'm not substituting. There's no u involved here. I'm just writing it a different way. I'm writing my quotient, 4x minus 7. Can we integrate those things? Yep. Okay. And then we're going to have plus, we ended up with negative 3, right? Negative 3 is the remainder? Negative. Okay. Minus 3 over x minus 2. Not something that I can integrate. Yes, something that I can integrate. 4x is 4x squared over 2 minus 7x minus 3 times the natural log of the absolute value of x minus 2. I'm going to do this from 3 to 5. Now, if you're saying, we'll go down here. Whoa. Woo. Something like that. Why did you not u-sub when you saw this? Like, that looks like I should substitute. Okay? Let u equal x minus 2. If I have the derivative of something that's just going to spit out 1, when I do the u-substitution, it's going to be very boring. And then I'm just going to end up with the same thing that I had in there. There's no extra pieces on there. If it's just x, it's not like 3x, 2x, negative x, plus or minus something. I don't really need to go through the whole routine of substitution. I kind of know where that's going to go. Okay, but I could if I needed to. I'm going to put the 5 in. Charles. I'll put 5 in. I got 2 times 5 squared. 2 times 5 squared is 50. I'm going to put 5 in here. I get 35. I'm going to put 5 in here. I get natural log of 3. I'll put 3 in. 2 times 3 squared, 18. 7 times 3. 3 times the natural log of 1. Put the 5 in, put the 3 in. I got 15 minus 3 natural log of 3. Minus 18 minus 21, negative 3. So I'm going to go minus negative 3. And I'm going to go minus a negative there. So minus, hey, wait a minute, that's 0. Natural log of 1 is 0. Done. Okay. 15 plus 8, we get 18 minus 3 natural log of 3. Nothing that is in this Delta Math assignment today is like earth-shatteringly different than something that you have seen before, other than recognizing that you have to do long division before we get to this substitution part. I will tell you in past years, this Delta Math assignment has been problematic because people don't know how to simplify logs. And it wants you in the answer a lot of times to combine things into a single logarithm. So if I come up with an answer and I've got natural log of 3 plus natural log of 4, and I want to write that as one single logarithm, that is the natural log of, you know the rule on that. It's 12. If I have the natural log of 3 minus the natural log of 4, I divide. Natural log 3/4. If I have natural log of 2 raised to the 1/2 power, that's the same as 1/2 natural log of 2. If there's an exponent inside my log, I can pull it outside. If there's a number outside my log, I can pull it in as an exponent. Okay? If there's a log outside, log, I can burn it. It's the second fire reference in 1 hour. Do I have problems? Maybe. Okay. Are we ready to go? We want to try some of these problems from Delta Math.
Yes.
You think we can do it? Give it a try. If you get stuck and something's giving you trouble, let me know. Let's see what we can do. Nobody is going to watch this 26-minute video.